In the previous episode, we looked at the three software layers. Well, we actually touched on each briefly. But today, specifically, we're going to expound on each and talk more about their responsibilities, the building blocks or components, and how they interact with each other. Then later on in the video, we're going to open our IDE and see how these layers are applied in our case study app, the BuildLog app. So, before we continue with our discussion on the three layers though, here's why I never start with code. As developers, we have an itch to almost immediately implement our app ideas in code. And this sometimes happens immediately we get that idea. While this might work for simple and personal projects, it's not the most efficient way to handle our incoming projects as developers. Here are problems I personally run into with this kind of approach. Number one, multiple iterations. Well, I saw that I was iterating a lot on features, modules, and later the entire project. And I was asking myself, what was I trying to perfect? What kind of mark do I want to reach? Number two, with multiple iterations comes a longer development period. True, because the apps that I used to take a month were taking me more than a month, maybe 3, 4, or even 6 months. And finally, every sitting was time-consuming and unproductive, unfortunately. So, with the problems in the open, is there a way we can develop or ship faster, iterate less, and in the process still maintain productivity and efficiency? Well, the answer is yes. But first, we need to understand one thing. Software construction is an activity in the software development lifecycle. And this was actually cited by Steve McConnell in his book, Code Complete 2. And there's other activities in the SDLC, but we're not going to talk about them that much because our focus currently is on a part of the activities like high-level design and construction. Software construction, in this case, being us coding and debugging. But mostly, we are talking about the high-level design before we even open our IDE and implement our case study. We've seen there's a better way to handle our projects than code first. So then, how does the solution look like, or how does it work? So enter an approach I like to call design first approach. So basically, the idea is in this approach, we want to get a mental blueprint of the software we are building, and then we boil down to the individual features. And also, this is the point when we want to separate what's nice to have from the core MVP. And this is actually very important because it's actually helping us to escape scope creep. So then, how does the design process look like? So for me, how I will actually approach this is, the first step is to step away from the computer, from my IDE, get a book and a pen, and start to think through the whole software. And I will ask myself a couple of questions like, what problems am I solving? Who are the users that I'm designing the solution for? What are the core features? And what are the business concepts and how they interact? So basically, at this point, you just want to ask yourself questions that will help break down that big problem into smaller units, or we can even call them features. And it turns out that this is the point when I discover roadblocks. And it's better for me because this is actually in paper. I've not started implementing anything yet. So this process goes on for the entire application and then down into the features. The main reason I design first before writing a single line of code is simple. I want to understand the project before I build it. And I want to understand it well enough that once I open my IDE, I have a good idea of what I am doing. And get this, this means not inventing solutions on the fly. Other core reasons include design gives direction. This means we have a bird's eye view of the entire system. We can see major components, we understand how features fit together, we know responsibilities of each part, and most importantly, we know what we are building. In case you haven't noticed, this answers my previous questions. What am I trying to perfect? What mark do I want to reach? Reason number 2, direction leads to precision. Now, once the destination is clear, implementation becomes much more focused. This in turn means fewer rewrites, less feature creep. And most importantly, development becomes faster. Not because we are typing code faster, but because we are making fewer unnecessary decisions while coding. And finally, as we've seen from Steve McConnell's book, Code Complete 2, coding becomes construction and it's part of the SDLC. So we are not going to take much time into it. So then, this means by the time we open the IDE, the difficult questions have already been answered, the architecture is clear, responsibilities are defined, and implementation is no longer an act of discovery. It's just an act of construction. So that has been a productive discussion on why I never start with code. Now, back to the original, the 3 software layers. We will start with the user interface layer. The UI layer has to do with presenting information to the user and collecting user input. That's basically it. So it shouldn't really contain business rules or any kind of data access logic. So apart from handling user interactions and presenting information, the UI layer also is responsible for managing UI state and coordinating with its nearest neighbor, the domain layer. So what really makes up the UI layer? What are its components? We have screens, we have controllers, UI state, and widgets. Widgets in this case being the individual building blocks of a particular user interface. So what usually happens? When a user performs an action, the UI forwards that request to the domain layer. When the domain layer returns a result, the UI simply reflects the new state. So we expect a flow like from a user to the UI to the domain, that kind of flow. On to the next layer, the domain. So this is the heart of the application, mostly because it's where business rules and behavior live. And for this reason, it shouldn't really rely or depend on external frameworks. So it doesn't know how to store data or how to display it. Instead, what it does is it coordinates the work between the UI and the data layer. It sits at the middle, think an engine. So we expect UI, domain, and data. So what really builds up the domain layer? We have entities, use cases, repository contracts, and finally the business rules that we talked about. Right, on to our final layer, the data layer. So this layer is mainly responsible for managing data, and it also communicates with the outside world through our RESTful APIs or any other external framework. And it really doesn't matter where the data comes from. It could be local database, an API, local storage. This layer mainly hides those implementation details from the rest of the application. Okay, so what really makes up the data layer, or what are its components? We have the repository implementations, data sources, models or DTOs, and finally the mappers. So its neighbor, the domain layer, simply just asks for data without worrying where it comes from. So that actually completes our 3 layers. And if you've noticed something interesting, none of these layers are actually complicated on their own. Each has a single well-defined responsibility. The complexity of an application doesn't come from the layers themselves, it comes from mixing their responsibilities together. So, putting everything together, we get a stack with clear responsibilities and a clear communication pipeline, all the way from the UI, the controller, use case, repository contract, the implementations, data sources, and finally, the database or API. So, that concludes our discussion. Let's head straight to our IDE.